As we begin our work on scientific notation, converting it back and forth, now that we have negative exponents, I don't want you to focus on trying to memorize whether you move the decimal to the right or to the left. If you focus on what makes sense, you will do better. Because, I can tell you if there's a negative exponent that you're going to move the decimal to the right. However, do you move it to the right when you're converting from scientific to standard? Or do you move it to the right when you're moving it from standard to scientific? So it's not easy to say, well, there's a negative exponent, so I always move it to the right. There's a positive exponent, so I always move it to the left. Well, not quite, because it depends on whether you're converting it one way or whether you're converting it the other. So it's the opposite depending upon how you're converting it. So if you focus in on memorizing that, then it's going to take away that element of thinking and understanding. And then you're going to get caught up on going back and forth. And when is it that I move it to the right when it's negative? And when is it that I move it to the left when it's positive? Or whatever. So really honestly, look at these numbers. We're going to do obviously 7, 8, 9, and 11. But you can look at these. Look at the decimals. Look at the exponents. Notice which ones are positive and negative. If it's a negative exponent, your number is going to be teeny tiny. You are going to have a itty bitty little decimal. So I know that this is going to be much, much, much smaller than 1. When they're negative exponents, it's because these are itty bitty, minuscule, tiny numbers, most of which we don't ordinarily see in normal life. The reason that we have this system of scientific notation is explicitly for numbers that are way too big or way too small to write in standard form with any sort of understanding. Most, but not all, most of the numbers that you work with when doing scientific notation are going to be extremely big or extremely small. Just like with the scientists, most of the numbers that they're working with when using this form are going to be extremely big or extremely small. So keep that in mind when we're doing this. When I see that negative exponent, especially, when we get to bigger numbers like a -5, a -6, a -7, these aren't too big or small. When you've got a -1, a +1, -2, +2, those aren't too big or too small of numbers. But the bigger the exponent, whether it be positive or negative, the more extreme the number is. So just really focus that on mind. I know this is a big number because it's a positive exponent. I know this is a small number because it's a negative exponent. So when I write it, when I convert it, I'm going to make sure that the number I convert it to will reflect whether I can tell it's big or small. And this has a negative exponent. I know that my decimal is going to go way that way. And I'm going to have 0.000. I'm going to have a lot of those. I'm converting these into regular notation. So these are going to be regular numbers. And I know these regular numbers are going to be extra tiny or extra big. When I move this to the left 5 places, I'll end up having 1, 2, 3, 4 zeros before the 4, 5. And I like to go ahead and check my work to make sure. After I've written it, now I can physically move my decimal 5 places. It started here between the 4 and the 5. I can go 1, 2, 3, 4, 5, and I confirmed it. I would prefer that your final answer doesn't have all the little loop-de-doop-de-doops in it, because when it does, it's often very difficult to find the decimal amongst all the little scribbles all in there. It's fine to write it out and do the little thingies. However, let's make sure that your answer is very legible. 10 to the 5th power, I have 1 digit already, so I've got to move it 5 places. This is a big number, so I'm going to move it 1, and then I'm going to have 4 more places to move it. So I move it 1 place, 2, 3, 4, 5. And then I'm going to check. 1, 2, 3, 4, 5. There, got it. Now, this is a big number, so I'm going to go back and put commas in it. 550,000. With your big numbers, you need to put commas in. Decimals don't have commas in them. I guess because it's so easy to get them confused with the decimal number, but you don't ever have commas to the right of the decimal sign. So, number 9, it's a -1. I'm not going to move it very much. It's not going to be that small of a number, but it is going to be a small number, and it is going to be less than 1. So when I move it one place, it ends up before the 6. Right there. And I'm going to go back and put a 0 before it. It's just a good idea to have a 0 before a decimal. You don't have to do it, but it helps you see the decimal there. You see my negative numbers? They're all smaller than 1. This one's negative, so I know it's going to be smaller than 1. I'm going to move, that's one place, and I have to move it 5 places, so that means I'm going to have 4 zeros. 1, 2, 3, 4, 2, 4. And just to be sure, it's the decimal started between the 2 and the 4. 1, 2, 3, 4, 5. Yep, that's it. The nice thing is after you've already written it and you go back and check, you don't have to really draw it. You can just really quickly check. It's really easy to check when you have the right number of digits. Now down to the bottom part, we are doing the opposite. We are converting it to decimal form. I know, because this is a teeny tiny number, this is going to have a negative exponent. I don't have to try to memorize a rule that says, well, if I move it to the right, then the exponent is going to be negative. If I move it to the left, then the exponent is going to be positive. Well, yeah, that's true, but you really don't have to try to memorize that. When you look and you see, that's a really tiny number. It's going to be negative. That's a big number. It's going to be positive. That's all you have to focus on. So when I write these in exponent form, with a scientific notation, I always have the decimal after the first non-zero digit. So you're always going to have one digit before the decimal when you put numbers in scientific notation. So that first digit, I'll have a decimal after. And I can, number 11. That's interesting. We'll do 11 together. I tried to trick you on that one. I'm going to add 11. That's funny. I don't know how I missed that. Okay. So now, I'm just going to go through and write all my non-zero digits times 10. All right, so it's going to be after this, so it's going to be 4.5. Oh, look, I don't even have any zeros in here, so I've got to write down the whole number. Yeah, these are not typical numbers that scientists will encounter. Yes, they will encounter these, but not typically. Most of the time, when scientists are working with numbers that need to be written in scientific notation, most of the time they'll be written like that. And occasionally they'll have numbers like this mixed in with those, but most of the time they're going to have a lot of zeros either to the right or to the left, which is why they choose to write it in scientific notation. So, yeah, they did these. These are not typical. Many of these are not. So 7.54256 times 10. 8.8. But even still, it's easier to compare this when you've got when all the numbers are smaller than 10. Then you can just kind of look at that first digit. That's 3, that's 4, that's 7, that's 8, and you can get a better comparison. Now, obviously, if the exponent is negative and the exponent is positive, you're not really able to compare the numbers together as accurately as if, is with all the positive exponents, you can compare those numbers together, and all the negative exponents, you can compare those numbers together because they're relatively the same. 1.8907 times 10. All right, now I'm going to go back. This is obviously negative. I don't even have to try to think, okay, do I move it to the right or the left? It doesn't matter. This is negative because it's a tiny, tiny, tiny number. Now, what I do need to know is how many places do I move the decimal. That's the important thing. So let's go 1, 2, 3, 4, 5, 6. So it's to the negative 6th. There are no zeros in this, but it can still be written in scientific notation. To go from here to here, I have to move the decimal 1, 2, 3, 4 places. It's positive because this is a big number. This is also a big number, so it's going to be positive. This one already has a decimal in the middle of it, so I'm only moving it 2 places. 2 places. This is an itty-bitty teeny tiny number. I'm going to move it because it's an itty-bitty teeny tiny number. When I move it my 3 places, it's going to be a -3. 1, 2, 3. Yes, just checking. It's always good to check. Now, the reason I wanted to do this one with you is because it's already got a decimal after the first digit. So if you put it in scientific notation, you've got to reflect that you don't have to move the decimal. So it's going to be 10 to the 0 power because that means 1, and that means you multiply it by itself and you get itself. So go ahead and finish this. Remember to focus on what makes sense and not get caught up on, do I move it to the right, to the left? What's that rule? How does it work? It just has to make sense, and then you'll do really well.